Hello everyone, today in this video we'll be discussing the super important questions of OS module 2, and in this video we'll have all those questions which you need to know from the exam point of view, and make sure watch this video till the end. You can easily score more than 80% marks, and please do like and subscribe, it helps me make more videos like this. So without wasting more time, let's get started. These questions are the repeated ones in the previous year and previous schemes papers. Okay, so the first question is, with a neat diagram, okay, explain the states of process, okay, with a transition diagram and process control block. So two questions are asked here. First, you have to explain the states of a process with a transition diagram, and second, we have to explain process control block with a neat diagram. Okay, so what are the states of a process? Okay, process is the way of doing thing. From one state we have to go to the other state, and from there we have to go to the other state until we reach the final state. Okay, when we reach the final state, the process is completed. Okay, so there are five states in a process. The first one is new state. Okay, new state, what happens? The process is in the stage of being created. Okay, when the process is getting generated or created, that is the new stage. Second is the ready stage. Ready is the stage where the process has all the resources it needs to run. Okay, there are all the resources present, and the process is waiting for some command to start executing. Okay, so this is the creation phase. This is the phase where it is ready, and third is the running phase where the instructions are being executed. Fourth is the waiting phase. Whenever there is a time gap in between where the input output operation is happening, that time the process stops in between. Okay, so that is called as waiting phase. And once all the operations got over, that is called the terminated phase. The process is finished its execution. Okay, these are the five phases, and this is the diagram for the states of the process. So here first we will be in the new state. Okay, the process will be in the new state, and once it gets admitted, it will go to the ready state. Okay, after it is ready, it should start executing. Whenever the time comes, it is starting executing here. Okay, scheduler dispatcher, when it happens, it will start running, and inside running there can three things happen. First thing is, it can interrupt and go back to the ready state. If any error happens, it will go back to the ready state and restart the process, or if the process gets completed, it will exit, or if there is an input output operation, it will wait for the input output operation to get over. Again it will go to the ready state, and then it will again resume and run here. Okay, so this is the diagram you need to make. Very important question. Next is the process control block. Okay, the process control block contains process specific information. So one process is running, p process is running, it has many information related with that. So all this information is stored in a block called as process block. Okay, all this information is stored in a block called process control block. There is some kinds of information. So what are those kinds? First is the process state, which is the state of the process, whether it is in the new state, ready state, running, waiting, or terminated state. Okay, so which of these states is it present in, that is called as process state, and this information will be there in the process control block. Second is program counter, where the program is currently executing at. Okay, and which is the next instruction to be executed and where it is present, the address of the next instruction. So program control always has the address, okay, of this current instruction as well as the next instruction. Third is the CPU registers. These registers vary in the number and type. So what these registers do, it will store some data. It are called as accumulators, index registers, stack pointers, and general purpose registers. Okay, and CPU scheduling information. This information includes all the processing priority, pointers to scheduling queues, and other scheduling parameters. So which process will execute first and which will be executing after that, all this information will be stored in the CPU scheduling information. About the memory, how much memory is present, wherever it is stored, what are the limits, what are the base address, all those things will be stored in the memory management information. The next one is the accounting information. Here the values such as the how much CPU is used and what is the real time time limits, the account numbers, the jobs or the process numbers, and so on. Those information which relate to the processes and the memories and the timing information is stored in the accounting information. Last is the IO status information, whether the list of IO devices connected are sending a data or they are requesting a data. All those things, list is made and that is stored in the IO status information, whether IO input output is happening or not. Okay, so this is the diagram which you need to make for the PCB. Very simple. First you will make the process state, as we discussed about the process state, which it is new, running, or it is terminated, or it is waiting, and so on. Okay, and what is the process number which is currently getting executed. The program counter points to the next program which is to be executed, means the next instruction to be executed. That address will be present here. This will have the registers, this will have the memory information, and this is the list of open files, which is nothing but IO status information, which all files it's executing. Okay, so this is all you have to make in the PCB. Okay, 1 2 3 4 5 6 things you have to make. After that, make it as a dot, because further information will also be present, which is needed to execute a process. Okay, so that's all for the first question. And moving on to the second question, we have, what is inter-process communication? Okay, what do you understand by the term inter-process? Inter-process means between the process. Okay, between two processes, if there is communication happening, if there is a data transfer happening, that is called as inter-process communication. Discuss message passing and shared memory concept of IPC. Okay, so first let's understand in detail what is inter-process communication. The communication happening between the process is called inter-process communication. Very simple. The communication happening between the process is called inter-process communication. The process can be either independent or cooperative. Okay, so this is a process P. It can be either independent or cooperative. Independent means this will execute and finish by itself. It does not require the help of any other process, and cooperative is the one which requires data from other processes as well. Okay, cooperation among the processes for information sharing and computational speed up. Okay, whenever we cooperate among the process, either we need some information, okay, some information which is there in the other process, that information is required by this process, or for computational speed up, to speed up the computation, some data if we take, we need not require that to calculate the data again, so we can just take and continue, so it will speed up the process, right? So these are the two reasons why we use the cooperation. Modularity and convenience is also two other factors why use the cooperation among the process. Modularity means if there is a big problem, it will be divided into small parts, and each part will be assigned to one process, and once they get completed, they will share the data and complete the whole solution. Convenience, it is convenient to do the cooperation among the process. The complexity will be reduced. Every process will be handling small tasks, so there is convenience in that. Handling is also easier. Okay, those are also two other reasons why we use cooperation among process. So cooperating among the process requires some form of inter-process communication. This is allowed by two models. Sorry, yeah, two models. There are two models in which inter-process communication happens. The first is shared memory, second is message passing system. By the name itself, you can understand in shared memory we'll be having a shared memory, and message passing will be doing the message passing. Okay, so this is the diagram which you need to make, very important. So here in diagram, what you will do, you'll write process A, process B, and you'll have a kernel here, and from here you will be having M outlets. Okay, what does M outlet do? M outlet will send and receive the data from the kernel. Okay, M is the like an agent. Okay, it will facilitate the transfer of the data to the kernel, and from the kernel this M will transfer the data to the other process. If you want to send some data from process A to process B, we have to send it to the kernel, and kernel will send it to the process B. We cannot directly forward it. Okay, this is called as message passing. We are passing the messages, M for messages. Next is the shared memory. In shared memory, what happens, there are two processes here, and whenever this data wants to be sent to the other process, it will just put it into the shared memory, and the process B will take whatever it wants from the shared memory. This is called as shared memory model. Okay, so difference between shared memory and the message passing. A region of memory is shared when the data is read and written. Okay, in shared memory we'll have a shared place, region, where we'll be reading and writing the data. Message exchange is done via process by using the object. Object is nothing but this one. This is called as object, the M thing. Okay, so the message is sent and received via that object. Used for sending large data. If you want to send large data, use shared memory. If you want to send small data, use message passing. Okay, next is system call is used only to create shared memory. Okay, for what system call is used? To create the shared memory. And here system call is used during every read and write operation. Okay, here every read and write operation, here only to create this shared memory. Message sent is faster. Okay, there are no system calls, that's why it is faster. Here message is communicated slowly because each time we read or write, it is calling a system call. Okay, these are the differences you need to write an exam for the shared memory and message passing. Okay, moving on to the third super important question, we have discussed in detail multi-threading model, its advantages and disadvantages with a suitable illustration. Okay, so we have to discuss what is multi-threading model. Okay, a thread. What is a thread? It is a basic unit of CPU utilization. Suppose that one task is present, and that task will be divided into different process, and for each process it will be divided into different threads. Okay, so this is called as one thread. There are multiple threads, multiple tasks can be performed at the same time. Common sense, there are multiple threads, we can perform multiple tasks. This type of programming is called multi-threaded programming. If there are multiple threads present which are performing the task simultaneously, it is called as multi-threaded programming. Okay, there are two supports for the threads that can be provided. First is at user level, second is at kernel level. Okay, and there are three ways of establishing relationship between user threads and kernel threads. Okay, first thing, understand that threading can be implemented at user level or kernel level, and to make the communication between user and kernel level, we have three ways. Okay, you got the point. So the three models are one many to one model, one to one model, many to many model. Okay, let's have a look. In many to one model, many user threads are mapped to one kernel thread. Okay, many user threads, one kernel thread. It is efficient, that's the advantage. Disadvantage, parallel runs are not possible. In the example, Solaris green thread. Okay, so here as you can see, there are many user threads present here. It's connected to one single kernel thread. Okay, this is called as many to one model. Second is one to one model. In one to one model, each user thread is mapped to one kernel thread. So here parallel run is possible, that is the advantage, but disadvantage is that creating user thread requires creation of kernel thread as well. So here more kernel threads are needed to be created. Okay, but parallel execution is possible. This diagram you have to make. Example is Windows XP. Next one is many to many model. In many user level threads are multiplexed to a smaller number of kernel threads. What does this mean is, here we'll be having multiple user threads, multiple kernel threads also. Okay, so what are the advantages? Developers can use as many threads as necessary. Kernel threads can run in parallel. When one thread is blocked, it does not stop the whole execution. Kernel will take some other thread. So options are more here, and parallel execution is also possible here. Okay, so there are many threads here, many kernel also here. So each of these will be mapped to either of these. Okay, so if one of the kernel goes, the other threads will go to the remaining kernel, right? So the parallel run as well as the failure chances reduces. Okay, what are the benefits of multiprogramming? Multiprogramming is responsive. Okay, means the program continues to run even if one part of it is blocked, because if one thread is connected to one kernel, and if this is gone, means this kernel will not be able to access this user thread, and vice versa, user thread will not be able to access the kernel thread. But if there are multiple kernels and multiple threads present, like multiprogramming, here if one of them fails, it can access through the other one, right? So that is the advantage. Responsiveness, if one continues to one is blocked, it continues to run still because of the other threads. Second is resource sharing. If there are multi-threads, all will share the same resources from the process. Okay, and economy. Allocating memory and resources for each process is costly. Therefore, more economical is to create context-switched threads. Okay, here it will cost less also if we share the resources and point multiple threads to a single kernel. Okay, and utilization of multiprocessor architecture. Threads may be running in parallel and hence efficiency is increased. Whenever parallel run happens, the efficiency is increased because output more output will be there in the same amount of time. Okay, what are the disadvantages of multiprogramming? First is debugging. Okay, debugging can be difficult because multiple programs are running simultaneously. We cannot identify which program has caused the problem. Second is cost. Implementing and maintaining a program can be expensive. Okay, maintaining the program can be expensive. Okay, wait time. Jobs may experience delays if higher priority tasks are constantly executed. Okay, wait time will be more if more priority tasks are constantly coming. Last is scheduling. Efficient CPU scheduling is required to manage the multiple tasks efficiently. Okay, so here a lot of scheduling algorithms are needed so that efficiently the program will run. So to run the algorithms, that is only costlier and it is time taking. So these are some of the disadvantages of multiprogramming. Okay, moving on to the fourth super important question, which is calculate the average waiting time and turnaround time. Okay, now see, this comes under scheduling algorithms. In that, the three most repeated ones were FCFS, RR, and SJF. Okay, FCFS is first come first serve, RR is round robin, and SJF is shortest job first. Okay, and this is non-preemptive. I'll discuss that when the answer comes. We will get started with the table here. Okay, I need you to remember two things. Okay, the first thing is there are processes. Okay, P1, P2, P3, P4. Four processes are there, and arrival time you have to remember. Arrival time is 0, 1, 2, 3. That means when time has started, process P1 comes at 0 seconds, process P2 comes at 1 second, process P3 comes at 2 seconds, process P4 comes at third second. Okay, that is what is called arrival time. Burst time is how much time P1 takes to execute, 9 seconds. How much time P2 takes to execute, 4 seconds. P3 takes 9 seconds and P4 takes 5 seconds. Okay, and they are all coming in the order P1 first, then P2, then P3, then P4. Okay, now we have to use FCFS and RRR, RR and SJF. These three we have to use to calculate the waiting time and turnaround time. Okay, so let's have a look. Waiting time is how much time a process waited before getting started. Simple. How much time the process has waited. Okay, means it has come, but it is simply sitting, it has not started, and it's not executing. Turnaround time, how much time from arrival to completion. This is very simple. Okay, this is very simple. We'll have a look. First, you need to understand what is Gantt chart. Gantt chart is made in this following way. Wherever we'll be explaining, we'll be depicting which process is there and what time stamps it has come. Okay, so let's get started. As I told you, remember there is process P1 to P4, and they have come from time 0 to 3 seconds. 0, 1, 2, 3, P1, P2, P3, P4. Okay, and the burst time, I can note it down somewhere. I'll not be coming up again here. 9495. Okay, if you remember, that's even better. 9495. Okay, now see Gantt chart. How you will make? First, make starting line here. Okay, just make a starting line here of any length and mark it as 0. Okay, now as you can as you remember, P1 came at 0th second, right? 0th second it came, so P1 will be starting from here. I'll write P1. Then P2 came at first second, P3 came at second, and P4 came at third second. Okay, so now after you have done this one, you have to see the burst time. Burst time means P1 takes 9 seconds to complete. Okay, and this is first come first serve. So whichever process comes first, that will be executed and completed. Okay, so 9 seconds P1 will run. This is the time period for P1. P1 runs for 9 seconds. After that it was 4, right? P2 was 4 seconds it will run. So P2 will run then 4 seconds after 9 till 13. After that P3 will also run for 9 seconds, 13 to 22. After that P4 will run for 5 seconds. Okay, according to the table, it will run for 5 seconds. So this is the Gantt chart you have made. Now you have to calculate the waiting time and turnaround time. For waiting time, you have to observe two things. When a process came, and when it started executing. Let's take each one by one. P1, when it came at 0th second. When it started executing, it's FCFS, so it started executing at 0th second only. So we'll subtract 0 when it came and when it started executing. Okay, subtract, you'll get 0 only because P1 is the first process and we are using FCFS, so the process will start executing at the same time. Okay, now like that for P2 when it came, P2 came at first second, right? First second it came. And when did P2 start executing? P2 started executing at 9th second. When P1 got over, P2's execution started. It 9th second it started. So 9th second execution started, it came at 1 second. So it was waiting for this time. Okay, it was waiting for 8 seconds. This is 8 seconds, right? So P2's waiting time is 8 seconds. P3, when it came at second, and it started executing at 13 seconds. So 13 minus 2. P4 waited for, it came at third second, but it started at 22 execution, right? So how much time it take? This is 22 minus 3, which is 19. Okay, so just add up, you will get 38 divided by 4, because 4 processes are there, you'll get 9.1. This is the waiting time for FCFS. Okay, next is the turnaround time. What do you understand by the term turnaround time? Turnaround time, very simple. When a process completed, okay, what time P1 completed? P1 completed at 9, P2 completed at 13, P3 completed at 22, P4 completed at 27. 9, 13, 22, 27. And when did P1 arrive? P1 arrived at 0, so it completed at 9, 9 minus 0. Okay, 9 minus 0. Next, P2, when it got completed? 13. When it had come? It had come at 1. So 13 minus 1, 12. Next, P3, it got completed at 22. P3 started at 22, means completed at 22, and it came at 2, right? So 22 minus 2, it is the turnaround time. Last is P4 completed at 27, it had come at 3. So 27 minus 3, 24. Add up all this and divide by 4, you'll get the average turnaround time. Okay, this is the average waiting time, 9.1. Average turnaround time is 18.2. Okay, now next one is the RR, which is the round robin. Here Q is given as 2 milliseconds. Okay, these are all in seconds. I mean milliseconds. I was just telling seconds, but you get the point, right? Next, RR. In round robin, what we do? In round robin, we have to calculate after every 2 seconds it will switch. Okay, suppose that let's assume there are three processes, p1, p2, p3. Okay, and after 2 seconds, after means p1 will start executing, after 2 seconds p2 will run, after 2 seconds p3 will run, and after that again 2 seconds p1 will run, after that again 2 seconds p2 will run, and after that again 2 seconds p3 will run. Like that it won't keep on going. Okay, that is called as the q value. If it is 2, it will run for 2 to 2 seconds. If it is more than that, it will run for that amount of time. Okay, now p1 when it came, p1 came at 0th second, right? So p1 started executing at this point only, and it will run for 2 seconds and then it will stop, and then p2 will start running. P2 when it came, p2 came at 1 millisecond, right? So first millisecond it came. So when p1 was running, p2 had already come here. In the first second p2 had already come here, then p3 also came here, then p4 also came, but they are not started executing it. Okay, they will come and they'll start executing according to the order. Okay, first p1 came, it started executing and 2 seconds got over, so it stopped. Then p2 had come, so p2 will also execute for 2 seconds and it will stop. Then p3 had come, p3 will execute for 2 seconds and p4 will execute for 2 seconds. After this is over, means p1 executed for 2 seconds, means p1's actual time was 9 seconds, right? It took 9 seconds to complete burst time, 9 seconds, right? So 2 seconds already it's over, that means remaining is 7 seconds. For that p2 it was 4 seconds, right? P2 had burst time as 4 seconds. 2 is over, so now after the first round only 2 seconds are remaining. P3 was 9, so again 7 is remaining. P4 was 5, 5 minus 2, that is equal to 3 seconds. P4 has executed 2 seconds and 3 seconds are more remaining. Now again P1 will get a chance from here. P1 again it will execute. It will execute for 2 seconds. Again what will the P1? P1 will be 7 again minus 2, that will be equal to 5. P1 5 is left. P2, how much P2 was left? P2 was already left as 2, then 2 also over, then it will become 0. Again P2 will not execute. Okay, then P3 will come here. Then P3, how much P3 was left? 7. 7 minus again 2, now it executed, so it will become 5. Now P3 is 5 milliseconds. P4, P4 how much it was? It was 3 seconds. Again 2 seconds it will run, so it will become 1 second. Okay, now again P1 will come. What was P1? P1 was 5 seconds, right? So 2 seconds again it will run. P1 will become 3 seconds. Now P3, P3 how much it had run? P3 also it will become as from 5 it will become as 3 seconds. 2 seconds it has executed. Then comes P4. See, P2 is executed, it will not come again, right? Because time is over, it goes off. Now P4, P4 if you remember only 1 second was remaining. So when 1 second is remaining, it will just execute for 1 second. Observe here carefully. 20 to 21, only 1 second it will execute and it will also get over. Now after that P1 how many seconds were remaining? It was remaining 3 seconds. So 2 seconds it will execute and switch to P3. P3 also 2 seconds it will execute and switch to P1. Now P1 and P3 both had 3 seconds here. 2 seconds executed, 2 seconds executed, so this became 1, this also became 1. So 1 second for P1 from 25 to 26, and from 26 to 27, 1 second. Okay, so see here 25 was there till 26, P1 will run, and from 26 to 27 P3 will run. This is how round robin works. Okay, it will divide the time, and once a process gets completed it will remove from the queue. Okay, so let's understand how to calculate calculate the waiting time and turnaround time. First, understand. Let's have a look at turnaround time, because waiting time is a bit different. Okay, turnaround time is same. Turnaround time, what is the meaning? Turnaround time means when a process completes minus when it arrived. Very simple. When it got completed minus when it had arrived. Okay, so P1 when it arrived is 0. When P1 got completed, 26. So 26 minus 0, 26. Okay, so P1 is 26. P2 when it had arrived at 1, right? P2 when it got completed, last instance of P2 is here, it got completed at 12. So 12 minus it had come at 1, so it will be 11. Okay, next P3, it had come at 2, it completed at 27. Okay, it had come at 2, completed at 27. 27 minus 2. um, P3 had come at 2, it is not 3. Okay, so this is one mistake I have made here, so let's correct this mistake. Okay, you get the point, right? So this is 2. Okay, 27 minus 2 is 25. Now 25. And what is P4? P4, when it had come at 3, right? P4 had come at 3, and when it got completed, P4 last instance is present here, 21. So 21 minus 3, that is equal to 18. Okay, so 18 is the time, turnaround time for P4. Okay, after getting the answers, we'll just add up them. Okay, we'll add up them. So you get the point right here. It is not 24, it is 25, and this is not 17, it is 18. Okay, so it will become plus 1 plus 1, so it will become totally 80. 80 by 4, it will become 20. Okay, so it is not 19.5, it is 20. So average turnaround time is 20, and average waiting time is, okay, average waiting time, let's discuss. You got the turnaround time, right? So that is same as the previous ones. Waiting time is a bit different. Why? Because here P1 started executing and it stopped also, it is not yet over. Okay, and again waiting is happening here. Okay, again P1 has to wait here, that will also be included. Okay, in the previous ones, once one gets started, it used to end, so there was no more waiting time. But here, once it starts, it has to wait again. Okay, this is the waiting time for P1. Like that, for P2 also there will be waiting time, for P3, for P4 also, and it will repeat also many times here. So let's understand how do we do this in a simple way. Okay, now understand. When did P1 come? P1 come at 0 second, and it started executing also. So initially P1's waiting time is 0. Next, P1 stopped here. When did P1 resume? P1 resumed at 8. It had stopped at 2. So this is 8 minus 2, 6. Next, P1. P1 stopped here. P1 started here. 16 minus 10, that is 6. Okay. Next, P1 stopped here and P1 resumed here. So 21 minus 18, 3. Next, P1 stopped here and P1 resumed after 25. Okay. So 25 minus 23, 2. Okay. After that, P1 stopped here and that's all. P1 has no more time, means it got completed. So we'll take these times and add. Okay. Same for P2. P2, when it started, P2 started at 2. Okay, and when P2 had arrived. Okay, P2 had arrived at 1, right? P2's arrival time is 1, right? P2 had arrived at 1 second, right? And when it started executing, it started at 2 executing. So it had arrived at 1 and it started executing at 2. So this time 2 minus 1, that is 1. Okay. Next, after that P2 stopped here. Next, P2, when it started at this. So 10 minus 4, 6. After that P2 stopped here, and after that there is no P2 because P2 is completed, so we will not take any more waiting time. Okay, once a process gets completed, the waiting time also stops. So this is P2. Similarly for P3, 2, 6, 4, 3, 1. Same way you have to do P3, just I showed as P1, and P4 also you'll do in the same way. So when you'll do that, you'll get an answer 53 here. Okay, we'll divide by 4, you'll get 13.2. This is how you'll calculate the waiting time for round robin. Okay, also round robin depends on the Q value which they have given. If they're given 3, the answer will be different because 3 seconds it will execute, then next 3 seconds, and so on. Okay, so these are some things you need to keep in mind. Moving on, we have the third algorithm, which is the most repeated one, SJF, shortest job first, and it is non-preemptive. What do you understand by the term non-preemptive? Okay, let's understand. So in SJF, what happens is the shortest job gets the priority. Okay, shortest job gets the priority. Okay, now I think it is better if I take the chart here and show you. Okay, see, tell me which is having the shortest burst time, means how much time a job takes to complete, and the shortest among them. So P1 takes 9 seconds to complete, P2 takes 4 seconds, P1, P3 takes 9 seconds, and P4 takes 5 seconds. So which is the shortest one? Shortest is P2, it takes 4 seconds. So this will be given the first priority. Second priority will be given to this one, P4. Third priority will be given to P1 because first this arrived. Okay, if this same time, FCFS will happen. First which arrived, that will be given the priority. Last P3 will be given the priority. Now what happens? See, P1 came at 0. 9 seconds are there, it will get executed. First 9 seconds will execute. Okay, after that got completed in 9 seconds, then we will check which one is shortest, because until 9 seconds all this has arrived. Okay, so once all this has arrived, then only we'll be able to check. We can't check at this point because in this point only P1 is present and it will start executing, and these ones will come after the 0th second. So this had already started executing and this came after that, so we will put this on hold. Okay, you got the point. We'll put this on hold. So this got executed 9 seconds. After that, these three are present, and the shortest time is this one. So P2 will execute after that. Okay, first P1 got executed, then P2. After that, comparison will be made. This is smaller, so P4 will execute. After that, at last P3 will execute. Got the point? Okay. So this is called as non-preemptive. Okay, this is called as non-preemptive. Okay, so why it is called as non-preemptive? See, as I told you, this has arrived at 0 second and it started executing. So when it started executing, 1 second got over. Then this process came. This process has 4 seconds completion time, and this has 8 seconds because 1 second is already over in P1, right? P1 started at 0. In first second, it has 8 seconds remaining, and P2 has 4 seconds remaining. So in non-preemptive, we'll continue with this execution. This will be on hold. Whichever new process will come in non-preemptive, that will be on hold. Okay, in non-preemptive, this will be on hold. Whichever new process come, hold, because it is non-preemptive. We can't interrupt in between. Okay, hold. This will also come and it will get on hold. But preemptive means we can interrupt. Okay, when we will interrupt and find out that this has 8 seconds remaining, this has 4 seconds remaining, we will pause this execution and we will resume this one. We'll start executing this one. Once this is over, until that time this has also come, then it will start executing this one. Then again comparison will be made, 9 seconds and this 8 seconds are remaining, then this will execute. After that, finally 9 will execute. This kind of execution is the preemptive one. Okay, so SJF will be discussing the non-preemptive one here. Okay, so preemptive one also same thing you need to follow, just a bit more complex it is. Okay, now first let's make the Gantt chart. P1, P2, P3, P4 arrival at 0, 1, 2, 3. Now P1 came, there was no other process, so it started executing and completed at 9. Next comparison was made. Shortest process is P2 with 4 seconds, so P2 will execute. Then 5 seconds it will execute P4, then 9 seconds P3 will be executed. Waiting time, everything is same. Waiting time, when did it come and how much time, means when did it start executing and how much, means when it came. Okay, see, when it started executing and when it had come. It started executing at 0, it had come also at 0, so waiting time is 0 for P1. P2, it started at 9 and it had come at 1, so it will be 8. P4, it started at 13, it had come at 3, so it will be 10. P3, it started at 18 and it had come at 2, right? It had come at 2, so it will be 18 minus 2. What is 18 minus 2? 16. Okay, so 16. So we'll add up this and divide by 4, we'll get a waiting time for this one. Turnaround time is also similar. When it completed, P1 completed 9, when it had come 0, 9 minus 0. Then 13 minus 1, P2 completed 13, it had come at 1. P4 completed at 18, it had come at 3. P3 completed at 27, it had come at 2. Add up, divide by 4, you'll get the average time also. Okay, turnaround time. So this is a very important question. Make sure you don't miss this one. It is present almost in all the previous year papers as well as model paper. Okay, moving on to the last question, we have explained 5 different scheduling criteria. Okay, what we have to explain? Scheduling criteria. Based on what criteria we do the scheduling used in computing scheduling method. The first thing is CPU utilization. The CPU, how much it is utilized more, that much better, right? We want to keep CPU busy as possible so that more tasks get completed in less time. Its utilization can range from 0 to 100. Ideally it's between 40 to 90, means percentage wise. Okay, most of the time. Throughput, second is throughput means how many processes completed per unit time. Okay, that is throughput. And turnaround time, it means how long it takes to execute one process. Okay, as I told you, the turnaround time is when it completed and when it arrived, that time difference. Okay, it arrived here but it completed here, that is the turnaround time. Waiting time, when it started executing and when it had come, that difference. Also if it waits in between, that also time we will be adding, that is the waiting time. And response time, It is the time taken for a process to start responding, not the time it takes to the output the response. Okay, responding means initial first response, second response it will come, third response, and final response also it will come in the slots it will come. But first when it started responding, that is called as the response time. Okay, that's all. If you found this video helpful, please do like and subscribe. It helps me make more videos like this, and don't miss any of these questions. And thank you so much for watching. I'll see you in the next one.